Okay, so let's take another look at constructors, calling constructors. Remember that if you declare a variable like this in Java, this might look like just a declaration, but not actually creation of the objects date1, date2. C++, this is different. If you say something like this, of course you need a semicolon here that's missing, but this would mean that you're setting up two objects and you're actually calling the default constructor, so even without the parentheses. You cannot later on, after you declare this, explicitly call the constructor. If you try to do that, you'll just get an error message, I believe. Let's just try it out. Actually, I haven't seen this for a while. I haven't tried it myself. Alright, so we have XYZ, and we declared a Y object, and now let's say Y dot XY. See, it almost seems like Eclipse is saying we can do this, but I think we'll get an error message, as the book says. XYZ. But I'm having a hard time typing stuff. And we can say 1, 0. So we're trying to call the constructor XYZ. Oh, it almost looks like we made it, but let's see if the compiler will let us do this. There it is. Okay, so try it. You will get an error message. Try calling the constructor explicitly. You cannot call it like other functions. So that's a difference between constructors and other member functions. You cannot call it explicitly. It's called sort of implicitly when you create the object. Okay, so you can call getX. You can call the getX member function, fine, but you cannot call constructors. And it's pretty much the same rule as in Java. Okay, so back to the notes. You cannot call the constructors. It looks like okay, it looks like it should work, and even Eclipse does not indicate that anything's wrong until you actually try to compile it, and then you get error messages. Okay. So the code for the constructor is just like other member functions. Of course, you don't have a return type. You don't have a void, not even a void or an int or anything like that. When you define the constructor in, let's say, a .cpp file, just like we did in for the XYZ class, you have to use the name of the class, colon, and then constructor, which is also the name of the class. And then the regular parameters, and then setting all of the statements that you would use. Okay, so there's another way to initialize data members. We'll get to, I think, in the next slide or the one after. Okay, so you might note that you have the same name around the scope resolution operators. This is actually the name of the class. Oops, this first one. And this is the name of the function. Excuse me. So this is the name of the class, this is the name of the function. In the case of the constructor, they're the same. So that's why it looks a little bit different. Okay, so there is another way to initialize data members, or initialize member variables, as they're called in C++. And that is to use the initializer notation, or the initialization section notation. How do you do this? You put in a colon after the constructor, and then you say data member name, and then in parentheses the value you want to initialize it to. So this is just like saying month equals month value. And you can have any number of data members. The one thing to watch out for is that C++ will always do these things in the order that they are declared in the class. So if your month comes after day, day will get initialized first, and then month will get initialized, regardless of how you put it in here. If you put it as assignment statements, it will do things in the order that you specify the assignment statement. So it's just a tiny bit different from making assignment statements. So let's just take a quick look at this in code. Okay, so let's say we take a look at the default constructor. That's a good one to use initializer sections for. And what we would say is, instead of having the things in open close curly braces, you would put it right here. You would say, I want to initialize the X data member and have it initialized to 0, and I want to initialize the Y data member and set it equal to 0 as well. 0.0 since it's a double, so you don't need this. So now what will happen is X, this variable X will get initialized, so its data member X will get initialized first and then the data member Y. And if you reverse the order, it'll still be X first and Y second. Here, if you use assignment statements, it will execute in the order that you specify the assignment statement. So it's a tiny bit of difference. A lot of times this is preferred. And actually, according to some coding conventions, they will say never initialize things in curly braces, always put them into the initialization section. So this is something we don't have in Java. So you can do it over here in the xyz.h file. You can do it in the .h file, or you can do it here as well. Let's do that. Here it would look like this. X is initialized to x underscore in. So this variable, or I mean, sorry, this thing can be the parameter that's passed in. Anything that's passed into here can go into these initialization section or initializers inside parentheses. And we can say y is going to be initialized to y underscore in. So this is just like saying x equals x in, y equals y in, except it goes into the initialization section. And C++ does certain things, guarantees that it will be initialized in the order that they are declared in the class declaration. So let's go to the class declaration. They are declared x first, y second. So it'll always be guaranteed that x will be initialized first before y. If you change the order, even if you put it in like this, if you have these initializers, and if you have y first, let's just do that. Then you're guaranteed that y will be initialized first, and then x after that. And sometimes this is important. So for example, you might say something like this: x times 3. And let's see if we get an error message. I hope not. Okay, so what is this saying? There's a warning, something about initialization. Okay, so double xyz, it's just a warning, and I think it's all okay. Oh yeah, so here it says, one of the warnings is x will be initialized after y. Perfect, exactly what we wanted. But it's giving us the warning saying that you really should put x will be, yeah, okay, perfect, exactly what we wanted. So yeah, so actually what it's telling us is that we should not do this, right? Because since we declared y first and x later, it'll do y first and x later. Yeah, so it's saying this we should not do. You should say this is equal to, let's say, 1, and this is y times 3 is what we should have done, because since we declared y first, it's going to initialize y first. And so now, even though we said x first, it's going to do y first and then declare and then initialize x later. Sorry for the confusion. So remember, the thing to remember is that this is what's important, the declaration. Here we reverse the order and we have y first, and so now it'll initialize y first and x later. Let's see what happens when we compile this. And let's see the warnings. These are not errors, these are just warnings. It's telling us x will be initialized after y. Perfect. So x comes after y, so x will be initialized first. So it's really telling us, you really might want to consider changing the order here as well, just to make it clear to yourself, because you might be misled. And it's just a warning, basically saying it'll work, but you should be careful about what you're doing here. And this time around, I think we're okay. And it's saying X will be initialized after Y. Okay. X will be initialized. Oh yeah. So it's telling us really, I think it's warning us about this one. Now, even though initialization of X does not depend on Y, it's telling us since we have declared things in this order, Y first, X later, you should have that order. Alright, let's see if this fixes everything. Compiles, yeah. Another thing to note is, that we are in the constructor, the X in goes first, the Y in goes later. That does not matter at all. X in goes first, Y in goes later. And see, no warning. What it's telling us is that even though if you have it in the other order, that's X initialized first, Y initialized second, it will do it in this order. Y first, X second. Why? Because that's the order in which we declared things. Okay, hope that's not confusing. I just switched everything just to show you. And you might want to switch it around and then convince yourself what order things will be initialized in. Okay, so it's just a tiny point, but sometimes you do stuff like this. You initialize one of the data members and you initialize the other data member based on an earlier initialization. In this case, you should probably put everything in the right order and all that. Okay, so this second line is called, these are initializers. This is the initialization section. This is always done before the statements in here, and if you're going to initialize variables here, you don't need to do them again here, right? If you're going to do them, if you're going to have an initialization section, you can just have empty curly braces, so you can have the body left empty. This is almost always the preferable definition, this version. That is, it's a preferable way of initializing data members, rather than having it inside the curly braces. So for the constructor, it's not just there to initialize data. It also often you do some checking too. For example, let's say you have a data member for age. You don't want the age to ever be negative, right? You want to do some checking. That is, you want to validate some of the input so that you don't just start off your classes, your objects with invalid data members or like negative age. Okay, so the body does not have to be empty. You can have something in the initializer version, and then you can do some checking and ensure that only appropriate data is assigned to the private member variables. Once again, a very powerful object-oriented programming principle. You can overload constructors, just like we saw. You can have a default constructor with no parameters and then a constructor with one or more parameters. You can have constructor with two parameters two constructors with two parameters each, as long as the parameters are different types or if the types have a different order, just like with member functions. And remember that with all functions, there's a signature of a function which consists of the name and the list of parameters, basically saying that's the type and the order constitute the signature. So int double is different from double int. Okay, so you want to provide constructors for all possible argument lists, and you might have many number of these. So I'll skip this example. Please take a look at it. This day of year example, it shows you some overloaded constructors. It's pretty straightforward. And it's from chapter 7, display 7.1.